This quantum reality is what scares scientists. That's the title of the video we're going to deep dive into today.
Oh, yeah.
And honestly, it's got me kind of intrigued.
Yeah.
Maybe even a little scared.
Mm-hmm.
What could be so terrifying about the quantum world? Well, luckily, we've got an expert here to help us break it all down.
I'm happy to be here.
We're about to take a journey into the realm of quantum mechanics and explore those mind-bending concepts that really challenge how we see the world.
It's a world where everything you think you know kind of goes out the window.
Exactly.
And you're forced to confront this possibility that reality is much stranger and more mysterious than we ever thought possible.
And the best part is no matter your level of physics knowledge, you don't even have to be an expert.
Yeah.
We're going to make this deep dive accessible and engaging.
For sure.
So let's just jump right in
Okay.
with this fascinating analogy that the video uses. The magic box.
Okay.
Imagine a box that can literally create anything. You name it, it's in there. An apple, a pencil, even a unicorn. But here's the catch. The box doesn't decide what's inside until you open it and look.
This is a great way to illustrate this concept called superposition, which is one of the cornerstones of quantum mechanics.
Right.
See, until we measure or observe a particle, it exists in this blurry state of potentiality.
Okay.
Like that magic box, it could be anything. It's only when we look that it collapses into a single state.
So if I'm understanding this right, it's like all these different possibilities are swirling around in the box.
Exactly.
And the act of opening it, of observing, forces it to pick just one reality.
Exactly.
Yeah.
And that brings us to what's called wave function collapse.
Okay.
This is the moment where the particle goes from this fuzzy cloud of possibilities to one fixed state.
Okay.
It's almost as if the act of observation is participating in shaping reality.
At the quantum level.
At the quantum level, yeah.
That's a pretty big departure from our everyday experience.
Right.
I mean, in the normal world, we assume that things exist, whether we're looking at them or not.
Right, and that's precisely what makes quantum mechanics so challenging.
Yeah.
But also so fascinating.
Absolutely.
It forces us to question those assumptions that we take for granted.
Well, before we get too far ahead of ourselves, let's take a step back.
Okay.
And think about how we even got here.
Yeah.
People have been trying to understand the universe for centuries.
Absolutely. Think about the ancient Greeks.
Okay.
They were trying to find these fundamental building blocks of reality.
Yeah.
They came up with those elements like earth, air, fire, and water.
Right.
And for a long time, we thought that atoms were these smallest indivisible units of matter.
But then along came modern physics and just kind of blew that idea out of the water.
Exactly. About a century ago, physicists like Einstein, Bohr, and others started to really unravel the atom.
Yeah.
They discovered all these particles like electrons and quarks.
Okay.
All these things that were governed by these new laws, the laws of quantum mechanics.
So it's like we zoomed in on reality and found an even more bizarre world underneath.
Precise.
And it turns out there's an even deeper level to all of this.
Yeah.
Quantum field theory.
Quantum field theory, yeah.
Suggests that particles aren't even the most fundamental aspect of reality.
That's right.
It's these things called quantum fields.
Yes.
Okay, so I think I'm going to need a little bit of help visualizing this.
Okay.
What exactly is a quantum field?
Imagine the universe not as empty space with particles floating around,
Okay.
but as this vibrant tapestry woven from invisible fields.
So instead of these tiny little balls bouncing around, we have this dynamic, energetic field that's constantly buzzing with activity.
Yeah.
And particles are just these like fleeting expressions of that energy.
That's a great way to put it.
Wow.
It's a pretty profound shift in how we understand reality.
No kidding.
Yeah.
And this brings us back to the idea that quantum mechanics reveals a world that's fundamentally different from anything that we experience. Cause and effect aren't so clear-cut.
Right.
And there's this inherent uncertainty built into the system.
You're right.
Yeah.
In the quantum world, you can't predict outcomes with absolute certainty.
Okay.
The best we can do is calculate probabilities.
So in a sense, the universe is playing dice with reality.
In a way, yes.
Wow.
And then there's the observer effect.
Okay.
The act of observing or measuring a quantum system actually alters the system's state.
Wait, so you're saying that our observation,
Yeah.
the act of looking at something, actually changes what we're looking at?
Yeah.
That's unsettling.
It is, and it leads to some really interesting philosophical questions.
Yeah.
Does our observation create reality or simply reveal it?
Wow.
These are questions that physicists and philosophers are still grappling with today.
So we've got this universe made of quantum fields.
Yeah.
particles popping in and out of existence.
Yeah.
And a reality that seems to be shaped by our observation. Where do we even go from here?
Well, there's a lot more to explore, but it's important to remember that quantum mechanics isn't just theoretical.
Okay.
It has real-world implications.
Yeah.
And has led to some pretty amazing technologies.
That's a good point. But before we get into the applications, I think we need to tackle one of the most famous thought experiments in physics.
Oh, yeah.
Schrodinger's cat. The cat that's both dead and alive.
It's a classic illustration of how this strangeness of the quantum world might apply to things that we see every day.
For those who haven't heard of this, imagine a cat trapped in a box with a device that has a 50-50 chance of releasing poison.
Okay.
Until we open the box and look. The cat is in a state of being both dead and alive.
Exactly.
Now, of course, we don't see cats walking around both dead and alive.
Right.
But the point of the thought experiment is to highlight just how bizarre this concept of superposition is.
It really is.
Especially when applied to everyday objects.
Exactly.
So it's a way of showing us that the rules governing the quantum world are fundamentally different from the rules we experience in everyday life.
Exactly.
And what's fascinating is that scientists have created something called Schrödinger cat states in the lab with real particles.
With real particles, yeah.
It's blurring the lines between the quantum and the classical in a way that makes you think.
It is.
I am officially mind-boggled.
Yeah.
So where do we go from here?
Well.
What other mind-bending concepts are lurking in the quantum realm?
Well, get ready for another layer of quantum weirdness.
Okay.
This video talks about this concept called Bell's inequality.
Okay.
And it's kind of a big deal because it challenges how we even understand reality.
Okay, break this down for me. What is Bell's inequality? Sounds pretty intimidating.
Well, it's basically a way to test whether the universe operates according to something called local realism.
Okay.
And essentially, local realism is this idea that objects have properties even when no one's looking at them. And that information can't travel faster than the speed of light.
So that's basically just our common sense view of the world.
Yeah.
Things exist whether we're looking at them or not.
Yeah.
And nothing can go faster than the speed of light.
Right, but here's the mind-blowing part. Experiments have shown that quantum mechanics violates Bell's inequality.
Okay.
So that means that either things don't have properties until they're measured, or information can travel faster than light.
Or both.
Oh, both.
Whoa. So either Einstein was wrong about the speed limit of the universe, or the act of observation is literally bringing things into existence.
Yeah, it throws a real wrench in our classical understanding of reality.
It's a big deal.
It is.
And it leads to some pretty wild philosophical questions.
Yeah.
Does consciousness play a role in shaping reality?
Right.
Is our perception of reality even accurate?
These are the questions that physicists and philosophers are still debating.
Wow, that's a lot to process.
Yeah.
But before we get too deep into the philosophy, I want to go back to something you said earlier.
Okay.
Quantum mechanics isn't just some abstract theory.
No.
It's actually had a huge impact on technology.
It really has.
So what are some examples of that?
Quantum mechanics is behind a lot of our electronics, lasers, and even medical imaging technology like MRI.
Oh, wow.
It's essential for understanding the behavior of stars, galaxies, the universe as a whole.
So even though it's strange and challenging, quantum mechanics is also incredibly powerful and practical.
It really is.
And it's constantly evolving.
Yeah, there's still so much that we don't know.
Like what?
Well, like this mystery of antimatter that this video mentions.
Oh, right. If every particle has an antiparticle, why is there so much more matter in the universe?
Right. It's like we set up a perfectly balanced equation, but the answer doesn't add up.
Yeah, where did all the antimatter go?
It's a question that's really puzzled physicists for decades. You see, when matter and antimatter meet, they annihilate each other.
Oh, wow.
Releasing a burst of energy. So if the Big Bang created equal amounts of matter and antimatter, they should have just wiped each other out.
So it's like the universe had this preference for matter over antimatter.
Yeah, but why?
Yeah, why?
We're trying to figure that out.
Uh-huh.
There are some theories about these like tiny asymmetries in the laws of physics that might favor matter.
Okay.
But it's one of the biggest unsolved mysteries in cosmology.
Well, this is all making my head spin.
Yeah.
Particles acting like waves.
Yeah.
The uncertainty built into reality.
Yeah.
The mystery of antimatter.
It's a lot.
It is a lot.
Yeah.
And speaking of particles acting like waves, this video also mentioned wave-particle duality.
It does.
Which is another one of those concepts that seems to just defy common sense.
It does.
So what is wave-particle duality?
Well, in the quantum world, particles can behave like waves and particles.
Okay.
It's almost like they have the split personality.
So it's not just that they're tiny and hard to see.
Right.
It's like they're fundamentally blurring the lines.
Exactly. Between a wave and a particle. And this duality leads to another crazy concept.
Okay, what's that?
The Heisenberg uncertainty principle.
Oh, yeah, the principle that says we can't know both the position and the momentum of a particle.
Exactly.
At the same time.
Right. And it's not just a limit of our tools.
Yeah.
It's a fundamental principle of the universe.
So reality is inherently fuzzy at the quantum level.
You could say that.
So with all of this weirdness, how do we even begin to understand reality?
Well, that's a great question.
Yeah.
If things don't have definite properties until they're observed,
Yeah.
and if just looking at something can change it,
Uh-huh.
what does that mean for the nature of the universe?
Yeah, it's like the universe is daring us to question everything we thought we knew.
It is.
But if the universe is this strange,
Yeah.
does that mean there are multiple ways to interpret it?
That's another great question.
The video mentioned different interpretations of quantum mechanics.
Yes, because quantum mechanics is so counterintuitive.
Yeah.
Physicists have developed all these different interpretations to try to make sense of it all.
So it's like we're all looking at the same abstract painting,
Yeah,
but each person sees something different.
that's a great analogy.
Yeah.
And these different interpretations,
Mhm.
they all offer these different perspectives on the same underlying mathematics.
So we've got these different interpretations, these different lenses through which to view the quantum world.
Yeah.
Can you give me an example?
Sure. One of the most famous is the Copenhagen interpretation.
Okay.
It's associated with Niels Bohr, and it focuses on the role of observation and measurement.
So what does the Copenhagen interpretation say about reality?
Well, it suggests that things exist in a superposition of states
Okay.
until they're measured,
Right.
and then the act of measuring forces them to choose a state.
It's like that magic box analogy again.
Exactly.
All those possibilities collapse into one outcome when we open the box.
Uh-huh.
So the Copenhagen interpretation doesn't try to explain what's happening behind the scenes.
Right. It's more about accepting the strangeness
Okay.
and just focusing on the predictions.
So it's kind of like saying, hey, the math works.
Yeah.
Let's not worry too much about what it means.
Yeah, it captures the pragmatic spirit of the Copenhagen interpretation.
I can see how that would be unsatisfying for some.
Right.
They want a deeper explanation.
Yeah.
You want to be able to visualize it.
And that's where other interpretations come in,
Okay.
like the many worlds interpretation.
Oh, yeah, the one with the parallel universes.
Yes, the many worlds interpretation suggests that every time there's a quantum measurement, the universe branches off
Into more universes.
into multiple parallel universes, each representing a different outcome.
So in one universe, Schrödinger's cat is alive, and in another, it's dead.
That's the idea.
So there are countless versions of ourselves out there living out every possibility.
It's a mind-bending concept, but it's gained traction because it avoids the whole wave function collapse issue.
Okay, so are there any interpretations that try to keep things a bit more grounded?
Well, there's pilot wave theory,
Okay.
which tries to bring back determinism.
So the idea that everything is predetermined,
Exactly.
no
No,
randomness.
Pilot wave theory says that there are these hidden variables that guide particles.
So instead of this inherent uncertainty, we've got these hidden forces controlling everything.
Basically. Yeah, but pilot wave theory also has challenges.
Like what?
Well, it's difficult to reconcile it with some aspects of quantum mechanics,
Okay.
and it introduces this concept of non-locality,
Non-locality.
meaning that things can influence each other faster than the speed of light.
So we've got these different interpretations, each one offering a perspective,
Mm-hmm.
but none of them really give us the complete picture.
Yeah, it's like we're trying to solve a puzzle,
Yeah,
but the pieces keep changing shape.
that's a good way to put it.
Yeah,
But that's part of what makes it so
it
amazing.
really is.
Quantum mechanics forces us to confront the limits of what we know
Yeah.
and embrace the mystery. It reminds me of that quote from the video, "Physics can't explain why the universe works as it does. It can only elucidate how it functions."
That's a good quote.
Maybe we're not supposed to know all the answers.
Right, but that doesn't mean we should stop asking questions.
Absolutely.
The pursuit of knowledge is what makes science so compelling.
So what's the takeaway for our listeners?
I think the main thing to remember is that quantum mechanics reveals a reality that's very different from our everyday experience.
Yeah.
It challenges how we think about the nature of reality.
But it also shows us that there's so much more to discover.
It does.
And maybe that's not a bad thing.
Yeah.
Maybe it's something to celebrate.
Right.
The universe is far stranger and more wondrous than we thought.
I agree.
This has been a great deep dive.
Yeah, it has.
We've explored superposition and wave function collapse.
Mm-hmm.
We talked about antimatter and Bell's inequality.
For it a lot.
We even went over some different interpretations of quantum mechanics.
Yeah.
And we learned that quantum mechanics may be weird, but it's also really powerful.
Uh-huh.
It's given us a lot of technology.
Yeah.
And it holds the key to understanding the universe.
It does.
So keep exploring these ideas.
Absolutely.
Keep asking those questions.
Yeah.
Never lose your sense of wonder.
Yeah, this universe is pretty amazing.